In this video, we're going to go ahead and discuss histograms. To start with, histograms are used for quantitative data. And histograms are kind of like the bar graphs for quantitative data. They're going to feel very similar in some ways, very different in others. Like bar graphs, I need two axes. So the x-axis is always going to be the class boundaries, which we'll talk about in a minute. And then the y-axis is always going to be the frequency or relative frequency. Unlike with bar charts, there should be no gaps between the bars. The only exception to this rule is if one of my classes or one of my categories has a frequency of 0. But if I've got two categories next to each other and neither of those categories has a frequency of 0, those two bars should touch. There should be no gaps, because unlike categorical data, quantitative data sits on a number line, and number lines are continuous. We're going to go ahead and do two quick examples so you can see what this looks like. So for our first example, I already have a frequency chart made for us. So I know that I was looking at the number of pets that students had at home. And in the particular class that I interviewed, a couple students had no pets. The biggest number of pets was 3. And then the frequency, the number of students who had that specific number of pets at home, was 3, 12, 8, and 2. And I want to make a histogram of this data. So for histograms, each number should have some width. So I'm going to come back here, and what this is my class. I need class boundaries. And to find class boundaries, I'm always going to go to this number that I start with, and I'm going to go half a step below. And 0 has no decimal places, so half a step below is going to have 1 decimal place, and it's going to be at negative 0.5. If I go a half step below 1, it's going to be positive 0.5, 1.5, 2.5. And then I'm going to do the same thing on the other side. Where is the upper boundary? I'm going to add half to each. So 0 plus a half is 0.5, 1.5, 2.5, 3.5. So when I draw my bar for the 0 category, that bar is actually going to have a width, and it's going to go from negative a half to positive a half. Other than that weirdness with the width of numbers on the number line, this should feel fairly familiar. So we're going to go ahead and we're going to draw frequency on the Y, categories on the X. And for categories, I need to make sure that the lowest boundary sits on the number line, the biggest boundary sits on the number line. So I need to go from negative 0.5 to 3.5 on the X. I need to go from 0 to 12 on the Y. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, plus 1 extra. So we're going to put 0 there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, perfect, happy face. I'm going to label it every other because I'm tired of writing. And I'm going to label that frequency. On the other side, I'm going to start at negative 0.5, and then I'm going to make every other, so 0.5, 1.5, 2.5, 3.5. And then this represents number of pets. Now all I'm going to do is I'm going to draw a bar from negative 0.5 to 0.5. That's 3 units tall. So I'm going to go up to 3. I'm going to go across. I'm going to go down. That's my bar for that first category. And then I repeat for the next group, which goes from 0.5 to 1.5, I should be at a height of 12. So all the way up here. The next group, which is 1.5 to 2.5, has a height of 8. And then our last group from 2.5 to 3.5 has a height of 2. A couple of things to notice before we do our second example. First, unlike bar charts where we labeled the middle of the bars, in histograms we're always labeling the edges of the bars. You will notice that these single digits did sit in the middle of those numbers. So 0 sits in the middle here, 1 sits in the middle here. You will also again notice those bars touch. They sit right next to each other because this list of numbers is contiguous. I know how to talk. They sit next to each other and butt up against each other on a number line. And so our graph reflects that. I want to do one more example where the data isn't grouped and we need to group it ourselves. So I'm going to scoot up here a little bit and I'm going to pull an example from the textbook. No, but I don't want stickers. I want pictures. Where are my pictures? There we go. Pictures. So in this example, we have data from 50 male students. Sizes are discrete since shoe sizes are measured in whole numbers and half units only. Construct a histogram, calculate the width of each bar or class interval. Suppose you choose 6 bars. So in this case, they're telling us we want to draw a histogram for this data set that goes from 9 to 14. And we want to choose 6 bars. They're telling me I need to group my data. Because if I were to list all of these different numbers separately, 9, 9.5, 10, 10.5, 11, all the way up to 14, I'd get more than 6 rows. So we need to talk about how to group data that hasn't been grouped. So if you need to group data, you're going to start by looking for your min, which I can see is 9. I'm going to look for my max, which is 14. And I'm going to add decimals here because some of my data goes out to 0.5. So technically all of my data has 1 decimal place out to the 10th place. I want to go half a step below the min and half a step above the max, just like I did for my already grouped data here. Half a step below, half a step above. Well, half a step below here, I need to go out one more decimal place. So this is going to be 9 minus 0.5, which is going to be 8.95. Notice that the half a step below, that 5 shows up in the next decimal place over. Similar idea to 14, but now I want to go half a step up, so that's going to be 14.05. My next step is I'm going to take this and I'm going to figure out how wide it is. What is the distance on the number line? So we're going to do 14.05 minus 8.95, and I'm going to do that on a calculator because I don't want to do it in my head. And we get 5.1. So the width on my number line is 5.1. And then I want to do 6 classes. So I'm going to take that number, 5.1, and I'm going to divide it by the number of groups or the number of bars I want, which is 6. So 5.1 divided by 6 is 0.85. And what I typically do is I round that up to a number that is easy to count by. I can't round it down. If I round it down, my biggest data point, 14, might not end up fitting in the table. So it's generally good practice to round whatever this is, my width divided by my number of boxes, and round it up if I don't want to count by that number. I could count by that number, and I could be precise. I could do 8.95 plus 0.85. But I'm lazy. I'm going to round up to 1 because that counting is easier for me. So we're going to start with our class boundaries. And then we'll fill in the frequency. And our class boundaries, we start with our lowest edge, not our minimum, but that half step below. So 8.95, and then I'm going to add 1, which would put me at 9.95. And then that number becomes the first number for the next row. And we add 1, and then we keep that pattern going. And I'm going to check 2 things. First, I wanted 6 rows. Did I end up with 6 rows? 1, 2, 3, 4, 5, 6. I did. Happy face. And I'm going to check that both my smallest and my largest fit in that table. 9 sits in this interval. 14 sits in this interval. I am a happy camper. Now all I have to do is go back through my data and count the number of data values in each. And when I do this, I like to color code. So I'm going to grab my highlighter. So I'm going to do the first in, ooh, that's too big. Let's bring that down. I'm going to do the first in red. So up to 9.95 would be the 9s and the 9.5s. So 1, 2, 3, 4. And then the 9.95s to 10.95s would be the 10 and 10.5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm pretty sure that's 14. If I miscounted, let me know. And then the next one is going to be the 11 and 11 and a halves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. And then we repeat. So next one is going to be the 12 and 12 and a halves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My next is going to be the 13 and 13 and a halves, and I don't see any. And then my last is going to be the 14s and 14 and a halves, and I only see one, which is my 14. A quick way to check that I filled out this column correctly is I was told there should be 50 students in my table. So I'm going to do a quick addition and make sure that I counted correctly. And I get 50, so I did. I am a happy camper. From here, this is going to work exactly like our last picture. I'm going to do two sets of axes. The first one needs to go up to 20, right? Frequency goes up to 20. That was the biggest number in the frequency column. And then I need 6 classes. And I'm counting by these numbers. So this is, and I'm going to write these sideways here. So this was 8.95, 9.95, 10.95, all the way up to 14.95. And I'm going to label that with what it is. This was shoe size, specifically US men's sizing. And then frequency is a similar idea. I think 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So counting by twos fits perfectly. And then I label this axis as my frequency. From here, we know how to draw bars. That first graph goes up to 4. My second class goes up to 14. Next one goes up to 20. One after that is 11, which is going to be halfway between 10 and 12. We have a 0, and then we have a 1, which is going to be halfway between 0 and 2. So that is the histogram for shoe size for this example. The big important thing, notice it's coming from a frequency table. So about half the time, you're already going to have a frequency table ready to go. You're just going to need to figure out that lower and upper bound. That's half a step between the edges of those classes. And that's just going to take a little bit of practice. All right, if you have any questions on how to construct a histogram, feel free to send me an email. Otherwise, I will see you in our next video.